Today we will continue the previous lecture and we will try to find the magnetic field at a point P due to a straight conductor. In previous lecture we have seen that the formula for the magnetic field at a point P due to finite conductor is this formula. You should understand this formula properly. See, here is a conducting wire, current I is flowing through it. You want to know the formula for magnetic field at point P. What I said earlier, that you should draw perpendicular from point P on that conductor. Length of that perpendicular is D. Length of that perpendicular is D. What are alpha and beta? You should understand it properly. In this situation, these two ends are on either side of the perpendicular. This end is on that side and this end is on this side. So when that end is on the upper side of perpendicular and this end is on the lower side of perpendicular, then you say alpha and beta both positive. But what will happen when both ends are on the same side of perpendicular? This is the perpendicular and both ends are on the same sides of perpendicular. Then in this case we will take alpha as positive and beta as negative. So you will write B is mu naught by 4 pi I by D sin alpha minus sin beta. It is very important to understand. In this case these two ends were either side of perpendicular, and in this case both sides were on the same side of perpendicular. Then beta is negative in this case. Consider this problem. This is an infinitely long wire. Now this is its one end, this is its other end. Now you want to calculate magnetic field at point P, right? So what is the rule? You first draw perpendicular from point P on the length of conductor. So this is length of conductor. You draw perpendicular and you write the formula. You write the formula mu naught by 4 pi I by D into sin alpha plus sin beta. So obviously D is the length of perpendicular. You will put A here, and this end is making angle 90 degree with the perpendicular. So alpha is 90 degree, and this end is also at the same on the same side of perpendicular. So this 45 degree, this is A, so this 45 degree will be negative. This 90 degree is positive and this 45 is negative. So you will write beta as minus 45. So magnetic field at point P is mu naught by 4 pi I by A 1 minus 1 by root 2. This is a V-shaped conducting wire. Current is coming from infinity going to infinity. You have to find magnetic field at point P, right? So first of all we should find the direction of magnetic field due to both these wires. This is conductor 1, this is conductor 2. You find magnetic field at point P. Keep your right hand fingers along the sense of current and just turn it towards P. Your thumb is upwards. So B1 is magnetic field due to wire 1 at P is B1 and it is upwards. What about this wire 2? This is current is going like this. Keep your palm towards that point at which you want to find the magnetic field. Then thumb goes outside. Then magnetic field due to this 2 is B2 and it goes outside. So net field at point P is adding up. So answer will be B1 plus B2. But this structure is symmetrical about this point P, right? So we will say both will be equal in magnitude. So answer will be 2B1. So what should we do? We find B1, right? B1 is, we should draw perpendicular from P to that conductor. This is the perpendicular, right? You write the formula mu naught by 4 pi I by d sin alpha plus sin beta. You see, this end is this side, this end is opposite side. This end is making angle 90 degree with the perpendicular. So sin 90 is 1, plus this end is on opposite side. So obviously it will be positive also. So this end is making angle 90 minus alpha. So mu naught by 4 pi I by d sin 90 plus sin this angle plus this angle, because alpha and beta are the angles which the two ends are making with the perpendicular. This is the perpendicular, these are the two ends, these are making angle 90 degree and 90 minus alpha. So alpha is sin 9, here you will keep put sin 90, here you will put sin 90 minus alpha, and at the place of d you will write what is d? So you have a triangle here, this is A, this is alpha, you have a triangle like this, this is alpha, this is A, so this is perpendicular D, so this is 90 degree, angle in opposite to alpha is A sin, this side is A sin alpha. As you know, you must know the this rule, that whenever hypotenuse is known, this is L, this is alpha, this is 90 degree, so this side will be L sin alpha and this side will be L cos alpha, right? So if this is A, this is 90 degree, so this will be in front of alpha, this side will be A sin alpha, so D will be A sin alpha, and these two will be added up, so we have multiplied by 2. So magnetic field at point P, we have calculated, it is this much. Now the same shape, current is coming from here going there, and you have to find magnetic field at this point P. Here it is not inside that V shape, it is outside the V shape. You have to calculate magnetic field at a point P. So first of all you should find the direction of magnetic field, right? So we should find the direction of magnetic field. You see, this current is going like this, you have to find magnetic field at point P. You keep your right hand fingers along the sense of current, palm towards that point P, thumb goes inside, so B1 is inside. Due to this, B1 is inside, and due to this part, you keep your right hand fingers along this, keep your palm towards that point, palm here, or simply you keep your right hand fingers along this and turn it towards P, your thumb goes down. So magnetic field due to this part of conductor is again into the paper. So both magnetic field will be add up. So magnetic field is just 2B1. If magnetic field is B1 due to this wire and B2 due to this wire, both are into the paper. Again I will repeat for the direction of the magnetic field. You keep your right hand fingers along the sense of current, like in this problem, this is the current direction, and you curl your fingers along P, your thumb goes into the paper, and for this you keep your fingers along the sense of current, and you keep your right hand fingers along P, towards P, turn your fingers around P, then you will get B2 into the paper. Now these two will add up, you will get B1 plus B2. So we must calculate one part B1 and then multiply it by 2, you will get the answer. First of all you should write formula here. What will be D here? D is length of, just extrapolate this conductor, draw the perpendicular, this angle is alpha, so this angle will also alpha, this angle is 90 degree, this is 90 minus alpha. Now this end and this end both are on the same side of perpendicular. This is perpendicular. Now these two ends are on the same side of perpendicular. So if 90 degree is positive, then 90 minus alpha is negative, right? Because both ends, this end and this end, are on the same side of perpendicular, right? So you will write alpha as 90 degree and beta as 90 minus alpha, right? But it has been taken negative. In place of D, you will write this is A, this is the triangle, and the length in front of angle is A sine alpha. So you will write this D is equal to A sine alpha. So it is very important question to find magnetic field at this point P. What you should do that you just extrapolate this, draw perpendicular, right? This end is here, that end is there, and this angle is alpha, this is also alpha. So this length will be A sine alpha, right? And that end is making angle 90 degree, and this end is making angle 90 minus alpha. Both are on the same side of the perpendicular. So if this is 90 degrees taken as positive, then this will be taken as negative. And D is A sine alpha. What we have done here, right? So we will write this formula. In place of D, you will write A sine alpha. In place of and 90 degrees taken positive, and this 90 minus alpha is taken as negative, right? And you have doubled this to get the net magnetic field due to the complete structure. It is very important, and it is a very important conceptual question. So you should try it by yourself. You just pause the video, draw the diagram by yourself, and get the net magnetic field at point P in both the previous problems. Here is the problem. Here is a current coming I in this wire. Here it is divided in two segments. Now it is again joined and it goes here. You have to find magnetic field at point O. You know that magnetic field at point A, O can be calculated. Suppose this is first part of the conductor, this is second part of the conductor, this is third part, that is fourth part, this is fifth part, this is sixth part. So we should first of all find the direction of magnetic field at O. You see, magnetic field due to these two parts is, you just curl your fingers along the ends and just towards O, your finger goes inside. For magnetic field due to these two wires, you curl your fingers along the sense of current and turn towards O, your thumb goes out. So due to this 2 and 3, magnetic field is into the paper, and due to this 4 and 5, magnetic field is out of the paper. So net field due to 2, 3 and 4, 5 is 0 at point P. Now we are left with only these two wires, this and this. So you have to find magnetic field at point O due to this wire and this wire. Now you calculate, again you find the direction of the magnetic field. Maybe it may be cancelled out. So keep your fingers along this, curl towards P, it is into the paper. And for this, keep your fingers along the sense of current, curl around P, it will be again into the paper. So they are both into the paper. They will not be cancelled out. So answer will be 2B1. So you just extrapolate this point, draw perpendicular. Obviously this length is A, because this length was 2A and this length was 2A. It was given this was 2A. So this is A and this length is also A. So obviously this is angle 45 degree. Now you will write the formula mu naught by 4 pi I by D. You will write the formula mu naught by 4 pi I by D into sine alpha plus sine beta, right? And in this formula D will be A and alpha is, this end is coming from infinity, so alpha is 90 degree and beta is, what should beta be here? See, this end and this end both are on the same side of the perpendicular, same side of perpendicular, so beta will be negative here, so minus sine 45, beta is 45 degree, and you just make it double because there are two wires. So net magnetic field be, this is the answer. Now next problem, a current carrying loop consisting semicircle and half of a square. This is half of a square, side of the square is A, 2A. This is A, this is A, this is A, and its one side is 2A and diameter is 2A of this semicircle, its radius is A. You have to find magnetic field at this point O, right? So what will we do? See, now here are four parts of the conductor. You can see first part, second part, third part, and fourth part. Now B net at O is obviously all will be added up. You curl your fingers along the sense of current and your thumb goes inside. So B is net. It is into the paper and it will be added up. So for point O, B3 and B1 are symmetrical, right? B3 and B1 are symmetrical. So you will write your answer 2B1 means B1 plus B4. See, this B1 and B3 are 2B1 and this is B4. B4 is due to this semicircle. What will be magnetic field due to B1 for this wire? So let us consider. For this wire, it will be, just you want to find magnetic field at O. You draw perpendicular. Length of perpendicular is A. Alpha is 0. This end is making angle 0 with perpendicular. Alpha is 0. And this end is making 45 degree with the perpendicular. So beta will be 45 degree, right? So make it 2 times, double this, and you will get 2B1. So we have got magnetic field due to 1 and 3. Both are identical towards O, symmetrical towards O. So both have same magnitude of magnetic field. What about B2, right? For B2, we have again written the formula. What is D here? So what the rule says, you draw perpendicular from this point to this length of the conductor. This is A. So D will be A here. So D will be A here. And what will be alpha and beta? You see there are two ends. These two ends are making angle 45 degree and 45 degree at the center. So alpha and beta both are 45 degree. So alpha is 45 degree and beta is 45 degree. So you have calculated B2. What about B4? B4 is half of the circle. Magnetic field due to complete circle is this much, mu naught I by 2a, and this is half of the circle. So you add all these, B1 2 times plus B2 plus B4, and you will get the result. I will suggest you to pause the video to calculate 2B1, again B2 and B4. You must check whether your answer is correct or not. This is the answer. So you must match your answer with this one, right? So it is combination of linear and circular magnetic fields, wires. Now we should come to next. This is now one corner of a square loop is rounded. This was a square loop. Now one corner of the square loop is rounded. You find the magnetic field at point O, right? So as you can see, there are 4 parts of this conductor: part 1, part 2, part 3, and part 4. Sorry, yes, 4 parts, 1, 2, 3, 4. But this part and this part are identical about O. This is length 2a, this is length 2a, and this is length a, this is length a, this is length 2a. So if this part is 1, this part creates magnetic field B1, and so this part will also create magnetic field B1, because this part and this part are symmetrical about O, right? So your net magnetic field will be, curl your fingers along the sense of current, your thumb goes inside, so magnetic field at O will be into the paper. So net field is B1 plus B1, that is 2B1 plus B2 plus B3. How will we calculate B1? So B1 is, we should write the formula. B1 is mu naught by 4 pi I by D sin alpha plus sin beta. D will be this, draw perpendicular. D will be A. What are alpha and beta? These two ends are making angle 45 degree and 45 degree with the perpendicular. So alpha is 45 degree and beta is 45 degree. So you will get B1. Double it. Don't forget to double it. So you will get 2B1. What about B2? B2 is this one. So you draw perpendicular from here. This is A. This end is making angle 0 with this, and this end is making angle 45 degree with this. So alpha will be 0, beta will be 45 degree, and D is A. What about B3? This is quarter circle, 1/4 of the circle, right? So magnetic field due to a complete circle is this much, and this is quarter circle, 1/4. So you just multiply it by 1/4. I will suggest you to pause the video and you just calculate 2B1 plus B2 plus B3 and you will get this answer. So please, I will suggest you to do it by yourself and then match the answer. Now we should come to this question. A sufficiently long current carrying conductor is bent as shown. Sufficiently long means this end is coming from infinite and this end is going to infinite. In midway somewhere it is bent in form of an arc which is subtending angle 120 degree at point P. Radius of this segment is, this arc is A. You have to find magnetic field at this point P. So there are three parts of this conductor, so we should calculate them separately, right? So come, here is part 1, here is part 2 and here is part 3, right? You see, every current, every magnetic field is adding up. You keep your right hand fingers along the sense of current, you curl it towards P, magnetic field goes inside. What about this? Curl your keep your fingers along the sense of current, turn towards P, it goes inside. So magnetic field due to this part and this part will be, magnitude will be equal and direction will be also into the paper. What about this part? Curl your fingers along the sense of current, turn towards P and finger goes inside, thumb goes inside. So answer will be this part and this part. Due to these two parts, field will be 2B1 and due to this part it will be B2, right? So answer is 2B1 plus B2 into the paper. What about B1? B1, formula for B1 is mu naught by 4 pi I by D sin alpha plus sin beta. What about D? D is length of perpendicular drawn from point P on the conductor. This is A, this is 60 degree. So this length will be A cos 60, that is A by 2. So you will put A by 2 here. What about alpha and beta? This end is making angle 90 degree with this end. So alpha is 90 degree here. And what about beta? This both ends are on the opposites, on the same side of the perpendicular, on the same side of perpendicular. So alpha is 90 degree and beta is 60 degree. But here will be minus and beta is 60 degree. And we will double it, right? So this is the formula. This is the case in which these two ends are on the same side of the perpendicular. So alpha will be positive, 90 degree will be positive, but this, for this end, this angle 60 degree will be negative. So I have kept minus here and sin 60. And D is A by 2 here, because if this is A, this is A by 2. Don't forget to double it. Now for B2, magnetic field due to complete circle is mu naught by 2, mu naught I by 2A, and it is 1/3 of the circle because making angle 120 degree. So it is 1/3. So you will add these two fields and you will get the net field and you should get this answer. So please pause the video, just solve this and you will get this answer, right? So don't just make notes and don't just watch the videos. You just involved in the every problem and you just draw the diagram by yourself. You write the formula by yourself, you put the values by yourself. There may be many mistakes, but slowly when you will practice, you will get expert in this. Now magnetic field at point P due to this system. See, this part will have zero effect in magnetic field and this part have zero effect on in terms of magnetic field, because whenever a straight wire is extrapolated, it has zero magnetic field along this line. So these two wires have zero effect in terms of magnetic field, and this wire is 1/3 of the field. So answer will be mu naught I by 2R. It is magnetic field due to a complete circle and this is 1/3 of the circle. So answer is this much. Now come to next question. You have to find magnetic field at point P, right? So see, due to this part, keep your right hand fingers along this, turn towards point P, your thumb goes inside, so B1 will be into the paper. For this part, curl your fingers along this, turn towards P, thumb goes inside, so this B2 is into the paper. What about B3? Keep your fingers along the sense of current, turn towards P, thumb goes inside, so B1 is again into the paper. So we will say B1 plus B1, these two are identical with respect to P. So 2B1 plus B2 is the answer. 2B1 plus B2 is the answer. 2B1 plus B2 is the answer. What about B1? This end of conductor is. B1 will be, you just write formula, mu naught by 4 pi I by D sin alpha plus sin beta. What about D? D is length of perpendicular. D is length of perpendicular. You just draw perpendicular from here. This is 120 degree. So this will be 60 degree. This is 30 degree. This end is, this is A radius. So length of perpendicular will be A cos 30. A cos 30 degree. Right. So you keep D as A cos 30, means A root 3 by 2. Now what are alpha and beta? This end is making angle 30 degree with the perpendicular, and this end is at infinite. It is making 90 degree with the perpendicular. So alpha will be 90 degree and beta will be 30 degree. Okay. And what about B2? B2 is 1/3 of the circle. Right. So you will write, keep here. You just don't forget to double this B1. Now you will get this answer. So magnetic field at point P is this much. Again I am saying, you pause the video, draw the diagram by yourself, and you just write down the formula, keep the values, and you check whether your answer is correct or not. Now come to this problem. Again, there are two parts of conductors which are straight coming from infinite, and one part is some circular arc, right? So formula, what is the direction of magnetic field? Keep your right hand fingers along this, turn towards P, out of the paper, due to this, out of the paper. Now for this, keep your fingers along the sense of current, turn towards P, out of the paper. So magnetic field due to all the parts are coming out of the paper, and these two are symmetrical. So we will write 2B1 plus B2. 2B1 plus B2. What about B1? B1 is, you write formula, mu naught by 4 pi I by D sin alpha plus sin beta. D is A here. This is 90 degree. D is A here, length of perpendicular. What about alpha? This end is making 90 degree with the perpendicular. So alpha is 90 degree. And this end is making 0 degree with the perpendicular. It is semi-infinite actually. So beta will be 0 degree here. Don't forget to double it. Now what is B2? It is 1/3 of the circle. Magnetic field due to complete circle is this much, and it is 1/3 of the circle. So this is this much. You add these two values and get this answer. You should check it. Now come to the next problem. Here is a shape given. You have to find magnetic field at point P. This wire is coming from infinity and going to infinity. Now you have to find magnetic field at point P. See, this conductor has 5 parts. First part is straight, second part curve, third is straight, fourth curve, fifth is straight. So magnetic field due to third part is 0 because that point is on that wire, straight wire. What is magnetic field due to part 2? See, keep your fingers along this, turn towards P, your thumb goes inside. So B2 is into the paper. What about 4? Keep your fingers along the sense of current, turn towards P, your thumb goes outside. So B4 will be out of the paper. But these are symmetrical about this point P, and so they will be equal in magnitude. So B4 will be equal to B2, and they are in opposite directions. So net field at P will be 0. So part 3 is making 0 field because it is on the straight conductor. P is on the same conductor, straight conductor. B2 and B4 collectively has 0 effect because they are cancelled out, right? Now for 1 and 2, see, magnetic field at 1 due to 1 is, keep your fingers along this and turn towards P. It is into the paper. And what about 5? Keep your fingers along the sense of current, turn towards P. It is out of the paper. B1 was into the paper and B5 was out of the paper. So all the current, this current, keep your fingers along the sense of current, turn towards P, B goes into the paper. For 5, keep your fingers along the sense of current, turn towards P, B goes out of the paper. So this B1 and B5 are equal in magnitude but opposite in direction. So magnetic field at point P due to B1 and B5 collectively will be 0. So B2 and B4 are making 0 field, B3 is making 0 field, B1 and B5 are making 0 field. So net field at point P will be 0, right, in this problem. Now come to this. Now how can we say it is 0? Ideal cross will be into the paper, ideal cross into the ideal cross be into the paper, and ideal cross be the, so magnetic field will be 0, right? So your answer is B1 plus B5. Ideal crosser is B into the paper. This is wrong answer. Magnetic field will be 0. Yes. Now we should calculate magnetic field due to this structure. See, there are 3 parts. This 1 and 3 are a straight part. Obviously you can see that magnetic field due to 1 and 3 is 0 at point P because they are a straight wire and this point P is on both the wires. So magnetic field at P will be 0. Now it is only due to this circle. Magnetic field due to circular part is mu naught I by 2a, and this 300 is 300 by 360. What fraction is circle? You should write complete magnetic field mu naught I by 2a into fraction of the circle. This 300 is which fraction? 300 by 360, this fraction. Angle, so you will write this is 5 by 12, I think 5 by 6. So your answer will be this much, right? Now we have to calculate magnetic field at this point P, right? So magnetic field due to B1 is how much? You just keep your fingers along the sense of current, turn towards P, it goes into the paper. For 2, it is like this, curl fingers, it goes into the paper. B2 is into the paper. For this, keep your fingers along this and turn towards P, it is again into the paper. So you will add all these magnetic fields, B1 plus B2 plus B3. B net will be B1 plus B2 plus B3, right? So B2 is obviously, so what about B1? B1 is due to this field. You just extrapolate it, draw perpendicular. So B1 is, you write the formula for this. What is D here? This is 300 degree. This total is 60 degree. This is 30 degree. So this is 300 and this is 60 total. This is 30 and this is 60 degree. So this length A is, this length will be A cos 60, right? So D will be A cos 60, that is A by 2. This end is making angle 90 degree here. So alpha will be 90 degree and this beta is 60 degree. But in this problem, both ends are on the same side of the perpendicular. So this beta will be negative here, right? And B1 and B3 are equal here, right? So just make it double. What about B2? B2 is 300 by 360. This is complete circle. In earlier problem, previous problem, you just calculated this much. So you add this one plus this one plus this one, you will get the result. Your result is, I have not the answer here. You can calculate magnetic field by yourself. Now the last problem of this type is that whenever, this is the problem, yes, whenever you have to calculate magnetic field at point P, so you should go like this. This is the last problem, I think, of this series. Okay, yes. So see, now this is the problem. I have bent first wire who was standing like lying like this. I have bent here, wire 1, wire 2 and wire 3. So as you can see, magnetic field due to wire 1 is, keep your fingers along the sense of current, turn towards P, it is coming out. So B1 is out of the paper. What about B2? See, keep your fingers along this sense of current, turn towards P, your thumb is outside. And what about this current? Keep your fingers along the sense of current, turn towards P, and this goes into the paper. And what about B3? Keep your fingers along the sense of current, turn towards P, it goes into the paper. So your answer will be B2 plus B3 minus B1. Obviously, B1 and B3 will be cancelled out. You will think like this, but it is not so. B1 and B3 are in opposite directions, but B1 B3 are in opposite directions, but they are not cancelling out because they are not equal in magnitude. So it is wrong to say that B1 will be cancelled out by B2. So we will write B1 as we must calculate B1. So to calculate B1, you just extrapolate the conductor, draw the perpendicular. This angle is 30 degree. Length of perpendicular is A cos 30, right? So this is A cos 30, right? So it will be length of perpendicular will be A root 3 by 2. Length of perpendicular is A cos 30. And this end is making angle 90 degree with this. And this end is making angle 30 degree with this. But both ends are on the same side of the perpendicular. So you will write minus here, right? So B1 will be calculated like this. B1 is this length, perpendicular is A cos 30, right? Now we should calculate B2. To calculate B2, B2 is here. B2, due to this, extrapolate this, draw the perpendicular. This total angle was 60 degree. This is 30 degree. So this angle is 30 degree also. This is 60 degree. You want to calculate the length of perpendicular. This is A. So in front of angle, this is A sin 30. That is A by 2, right? So D is A by 2 here. You see why they are not equal? Because in this case, the length of the perpendicular was A cos 30. And in this case, length of perpendicular was A sin 30. That's why they are not equal. So D is A by 2 here. And this end is making angle 90 degree with the perpendicular. And this end is making angle 60 degree with the perpendicular. But you will write minus here because both ends are on the same side of perpendicular. That's why you will keep minus here. Now we calculate B3 here. B3 will be the mu naught I by 2r due to complete circle into 300 by 60, 360, the fraction. Now you calculate all this. B1 and B3 are in opposite directions. So you will write B1 is out of the paper, B2 is into the paper, and B3 is into the paper. So your answer is B1 minus B2 plus B3. You should calculate it. Now you come to the last problem, right? Here you find the magnetic field at point P. I think I have done it earlier, so we should end here. So I will make two more lectures on this. So I was a little bit fast here because I have done a lot of work earlier in previous two lectures. So I will just suggest you to draw the diagrams, just learn the formulae, write the formulae, and keep the values and get the final answer. Please don't just make notes, don't just watch the videos, just go through it and work hard. Thank you so much.